This is another example at the extreme of the previous example where we have a large double width, double inlet fan with an évasé and inlet silencers. So if we have a look, we have the inlet box here under the code IB, and we can see that Centrix has calculated the number of stiffeners, 2 vertical and 3 horizontal across the box and the casing. Now let's have a look at the stiffeners again. So you see that we don't have a pattern here. Well, we do have a pattern here called inlet box. What does that show us? Centrix does not have standard bracing patterns for double width fans with integral boxes. So this feature now gives us the ability to calculate the number of stiffeners needed to go across the casing to prevent excessive deflection. So let's have a look what it's done. Again, we've got the maximum plate size for a deflection of 3. Results for combined casing and integral inlet box. There's the design pressure of 15 kPa. So again, we've got the usual information. So Centrix has chosen a quantity of 3 65 by 10 stiffeners, and the internal bracing rings, a quantity of 1 65 by 10. So we've got the maximum plate stress between stiffeners, plate natural frequency, 6mm plate deflection between stiffeners, and the gap between the stiffeners. The bending stress for the stiffener, and the stiffener deflection at centre of maximum span. So you can see that all these figures are generally acceptable. If we want to suggest a plate thickness, you notice that in the casing material we now have synchronized materials across casing and inlet box. So if we were to check that, if we change all these materials to say 5, you notice that they all change together. We can then click apply. And now we've got a reduced plate size because we don't want to exceed half the plate thickness. Let's have a look how we go here. Well, again, a 5mm plate appears to be adequate, and the bending stress and stiffener deflection is also okay. So we could go with a 5mm casing and inlet box here and scroll with 65 by 10. Now what happens if we go up to 25 kPa, for example? So Centrix has now said let's use 75 by 10 with a quantity of 3, and we have no warnings. Let's go to 50, go to some extreme values and see what happens. Again, we've got 4 stiffeners of 100 by 10. Suggested plate thickness is 8, but we don't have to change that to 8. We can simply look down here, make sure we don't see any warnings. We can just keep going, just out of interest. And you notice that the stiffener size goes up and the quantity goes up as well. Now what happens if let's go 100 by 10 with a quantity of 4, and let me set that and then calculate, and now we get a warning here. So these are the warnings: bending stress, deflection, and a warning for the plate as well. So one of the other things we could do is change that to say 8 and apply, and we get new sets of calculations. We've lost the warning on the plate, but we still have a warning on the stiffeners. So we might decide that we don't want to use any more than 4, but we can use 130 by 10, and that's got rid of all the warnings. And now we could, if we wanted to, we could show the layout drawing. So we've got transitions and évasé. Let's have a look at those. So at the moment we've just done the casing, the scroll and the inlet box. Let's have a look at the évasé. So at the moment that's a 13.2 kPa and it's 6mm thick. We might decide we only want 3mm. So let's apply. So we needed 1 flat bar. If we're going to use 13 kPa, we might decide that, well, I suppose it depends what we've put in for the design duty, what the outlet pressure is. I'm assuming that that's the outlet pressure of 13.2. If we assume it was an open outlet, it might only need a 1 kPa. And then we have, let's have a look. Let's just set that to 0 and set that calculate. We do get a warning. So 3mm might not be good enough, because don't forget we've got this plate weight to consider as well. So it's quite a reasonable size, 893 by 749, outlet, length 781. It's a decent length. So we can put a stiffener around the évasé for 1 kPa, or let's have a look at if we got 15 kPa, then that's still okay with a 65 by 8. Now if we have a look at our, what did we use there, 130 by 10 for 100 kPa, normally these pressures aren't going to be that much different, and you'd look at keeping these stiffeners the same size throughout the different components. So let's have a look at the rectangular inlet silencer. Very low pressure because this is an FD fan. So 200 by 12 on the silencer. Grade 2 for 200 by 12. So let's go back to 100 by 10. Set, calculate. So it looks as though for this sort of pressure, the inlet silencers were somewhat over-designed. And we can have a look at the inlet transitions. Again, we might want to make that 3, and it doesn't need any stiffening for that sort of pressure. Now once we close this, all those values are automatically saved. So if we open it again, we can see that the pressure has remained, that's remained. The évasé we looked at, the rectangular silencer we looked at, and the inlet transition. So once we start changing these things, it's automatically saved. But of course we can cancel all this, and we'll say yes. And now let's have a look. I think apart from the transition thicknesses, so that's back to standard. Yes, the thicknesses will stay as we wanted them to.